Hello again and welcome back. Maclaurin series and hyperbolic functions exam question for 10 marks, parts A, B and C. Let's get into it. Not going to read out the question because I'm conscious of time. So show that the fourth derivative is equal to minus 4y, given that y is equal to sine x, shin x. So product rule. So using, let's get started and let's do the math. Okay, we're good to go. So for part A, using u dv dx plus v du dx will help us to differentiate and find the first differential. So we're going to let u equal sine x, and v equal to shin x. And then du dx, of course, du dx is equal to cos x, and dv dx is equal to cos x. So now substituting back into our product rule formula, we have dy dx then. Dy dx, let's just extend the page. Dy dx, oops, let's get that right. So therefore I can say dy dx is equal to, well, u, which is sine x, dv dx, which is cos x, can never pronounce that right, however you want to pronounce it, and plus v, which is shin x, du dx, which is cos x. And that's your first derivative. Now you're going to use the product rule again, of course, to find, and because I'm conscious of time, we're going to have the second derivative. Let's go back. It's not nice writing. So d2y, because I've got to do this 4 times, yep, there you go, is equal to, when you use this, the product rule again, and you substitute the values in, you're going to end up with cos x cosh x plus sine x shin x, and then plus cos x cosh x, and then minus sine x sin x, minus sine x sin x. And that will give you a final result, once you tidy up here, of course, of 2 cos x cosh x, because your sine x and shin x will have gone. So you end up with 2 cos x cosh x for your second derivative. Using the product rule again for the third derivative, that will give you 2 cos x sine x, 2 cos x sine x, minus 2 sine x cosh x. And finally, once you use the product rule yet again, that your fourth derivative, well, you're going to get the answer of minus 4 shin x minus 4 shin x. Now, of course, you're going to let y equal, from the third derivative, you're letting y equal 2 cos x sine x. So that will give you minus 4 sine x, shin x sine x, minus 4, and I should put, that's incorrect here, careful. Yeah, that's shin x and sine x, and of course that will be equal to minus 4y, which is what they want you to have. You have to link y in hyperbolic, when differentiating hyperbolic functions, with whatever you let your value of shin x or sine x equal to. So yeah, you link it back to the value of y. So it's equal to minus 4y. And that's part A done. Part B, now part B, it's saying, hence find the first 3 non-zero terms of the Maclaurin series for y, given each coefficient in its simplest form. So let's go to our next page here, which, yeah, here we go, and we'll work here. I think that's a sensible course of action. So let's do the math. So using the second derivative and using the formula booklet, so if I write the second derivative, and of course it's got to be equated to 0, that will give me the value of 2. And the third derivative, and that will give me over 6, yep, dx, yep, oops, that is a 6, and that will give me the value of minus 8, and then the third one, so I'm going up here, and it will be the 10th derivative. So I use 2, going up in 2, 6, and 10. So, yep, sorry, 2, 6, it doesn't look like a 6 here. Let's make sure that that's a little bit clearer. Yeah, that's the 6th derivative. And the 10th derivative, over dx to the 10 is equal to 32. And of course that has got a boundary limit of 0. And now I go to the formula booklet and I use the Maclaurin series formula, and which is so use y, which is equal to, again, what have I done? Y to the 6 plus, and the formula says x y prime 0 plus, and that's x over 2 divided by 2 factorial, which of course it will be multiplied by 2, but we're just writing out what's in the formula, and that's gone y to the n and 0 plus what we have, x cubed now over 3 factorial, and y, again, y to the n and 0, which is our limits. And of course, so that's just writing out really, replicating what's in the formula booklet and of the Maclaurin series, and this translates to x squared over 2 factorial, and of course multiplied by 2, plus, and again, x squared over 6, because I use over 6 factorial, and that gave me minus 8, and plus, again, x to the power of 10, x to the power of 10 Oops, I've lost some information here. Let's go back. So that was x to the power of 6 over 6 factorial, and that gave us the answer of minus 8, and plus, a bit slow here, apologies for that, and the writing, minus 8, and plus, and it was x to the power of 10 over, of course, 10 factorial, and that gave us the result of 32. So, tidying that up, that gives us x squared minus x to the 6 over 90, x to the 6 over 90, and that is a 6, plus x to the 10, x to the power of 10 over 113,400. And that's part B. Done. For 4 marks. Now part C, find an expression for the nth non-zero term of the Maclaurin series for y. Well, we're just going to substitute in our values, again using the form from the formula. So that will give us, and it's very much like the binomial expansion really, 2 times minus 4 to the n minus 1, and that will give us x to the 4n minus 2 over 4n, and I put that in brackets, minus 2 factorial. And that's 10 marks.